Monday on the board, okay? You can use those as a reference. So I'd like you to pull your practice out of your bag, and while I'm taking attendance, I want you to work with your partner, and you're going to do just the problem that's on your desk. So it's fine if you have your work, if you just want to copy your steps from your work, but make sure you and your partner are alternating writing the steps. So one of you is going to use blue, the other one's going to use red, okay? And you're going to alternate the steps, okay? Are there any questions? Great, I'll let you get started.
Whoa. I hate it. So this is A.
Well, the first step we're going to do.
So but the equation is x equals negative b plus or minus. Squared.
Negative 2.
So if the first number squared is squared, you plus square.
It's a negative 2.
Well, I got all these wrong.
The first equation, you have to plug it into the formula. Just add the formula.
Wait, what?
Minus 4.
What, you said it's 2. So you don't put the square.
Chase, there's one on the opposite counter,
But
On top of
and then
A.
there's 3 of you on the desk.
Oh, I got it all wrong.
Division.
Wait.
Okay, make sure you're keeping your answers in exact form. So if you don't get a perfect square, that means you're going to have a radical in your answer.
and I just put 1 negative, right?
You forgot she forgot part of her steps.
Oh,
Okay, you forgot the denominator, there you go. Yes. Just one part. So you just want to kind of write over her step, and you can start your step over, but then what was your question? No, you shouldn't be getting a negative. So is it possible that you forgot to pull a negative sign from the equation? What's your A value? 8, good. What's your B value? Okay, and what's your C value? Are you sure? There you go. Okay, so Dominic, go ahead and fix your step, and then you can take over. We have to simplify the radical first. And don't forget, there's a plus and minus sign here that you dropped, right? Because this isn't multiplication.
Yeah.
This is going to be both addition and subtraction. Yes. Okay.
If that was
Is it a perfect square? No. Okay, so you're just going to leave it as a simplified radical. Does that make sense? Or do you have a question? Okay, did you get the simplified? How did you know it wasn't a perfect square?
because we tried the square root.
Okay, and what did you get in your calculator?
It just came up with 140. Yeah, and
Okay, so do you remember how we simplified? We were doing it a couple weeks ago. Okay, so what's the square root?
like
Or no? No, no, it's not the shape, right? So a perfect square is a number that has two factors that are exactly the same, right? So like 9 is a perfect square because 3 times 3 is 9. So the square root of 9 would be 3, okay, because the square root is asking for the factor that repeats.
Okay.
So you're gonna look in 151 and see if you can find any perfect square factors. So is 151 divisible by anything, or is it a prime number? That's what you need to figure out, okay? How are we doing?
Plug that in.
Chase. You can use your work. Oh. Yeah, you can have that out and use it as a reference. Do you have it? Here we go. Don't have it, okay.
So do I ask?
Yeah, she didn't do that right.
No.
You didn't do it right either.
Stop. You guys want to try another one while you're waiting? Yeah. So underneath that, you guys go ahead and start number 5. You can just do it underneath. You probably have enough room. Okay. So same thing. Keep alternating steps.
Do you want to begin?
Anybody else ready to check their answer?
So what's this before? What did you do? Carissa.
Good. Nice job. You guys have some time while other people are working. You want to start another problem? Work on another one? Okay. Do you want to work on a number 5? You're number 9? Okay. I'm not getting the same answer that you got. So Hunter, you want to help walk me through your steps. So what was your A value? Okay. And what's your B value? -4, good. And what's your C value? 0, okay. And so then how did you get from here to just 4? Okay, what's -4 squared? Okay, what's 16 minus 4? So I think what you did is you just multiplied the -4 by 2.
Well, we put it in a calculator.
Okay, show me how you did it. Here, you show me too. Okay, don't push enter yet. Leave that in your calculator. Okay. All right, now compare screens. What's different? Okay, push enter. You push enter. Okay. See, she's getting 16. And you're getting, yeah. Mm-hmm. Okay, so you need to figure out who's doing it right. Okay. All right. All right.
And then we did the square root of it.
Right, but I'm curious why you still have a radical sign if you took the square root of 16 and got 4. Do you still need the radical sign?
No.
No. Okay. You guys said number 9? Okay. And then, so that would be 4. Yeah, you took the square root again. You see that? So you took the square root of 16 and got 4, and then you took the square root again and you got 2. So that's why our answer is 10, right?
Wait, so we're not supposed to do the square root of 4?
You're supposed to take the square root of 16, because that's what's under this radical sign.
And then we're not supposed to do
And then this should not have a radical sign anymore, because that is the square root of 16. Okay, good job. So fix it. Fix it. Okay, which one do you have? 6. Okay. Good. What do you guys have?
just take away the radical, so like, just X.
Okay. So you have a B value of -10, an A value of 2, and a C value of 1. So this isn't going to work out to be a perfect square, right? It's not a perfect square. Okay, so you should still have a radical in your answer. So just leave the simplified radical in your answer. With the number underneath it, you're still gonna have a radical sign.
So just leave
No, because you'll have a radical sign up there and you can't really divide with that radical sign there. You're gonna have a complex number, is what it's called. So you'll have, your numerator will have a number plus the radical sign, and then your denominator will have a number. Does that make sense? Well, that's not simplified. Do you remember we simplified radicals? Right? You were killing it with simplifying radicals. Do you remember how to do that? So how do you simplify the square root of 12?
Are there like 7 hotels?
Are there any perfect square factors in 12? No?
Another thing I like to do?
Yes.
You guys talk about the beach
Well, under the radical sign, the square root of 12 would become,
Just go and bring all the go fishing.
well, if the square root of 12 can also be written as the square root of 4 times 3. What's the square root of 4? 2. So then the square root of 12 becomes 2 times the square root of...
Well, if it is something else.
I'll get back to you. Okay, I can tell by your conversations that we're finishing up. So here's what I'd like to do. Okay, here's what I'd like to do. First of all, I need your attention. I know I have your attention when you're not talking and you're looking at me. Okay, I would like you to compare answers with people who had like problems. Okay, so go ahead and put the caps on your pens. Okay. And you and your partner are going to be moving. You don't need to take your stuff. You're just going to take your piece of butcher paper, okay? And I'm going to have you just put your problem side by side with the other people who had the same problem as you. So if you had problem number 3, okay, you're going to meet at this table. If you had problem 4, you're going to meet here. Okay, problem 5 is going to meet here. This is going to be 6, 7, and then 8 and 9 are going to meet there. No, I'm sorry, 8 and 9. So it's 3, 4, 5, 6, 7, 8, and 9. Okay, so I need everybody up. Okay, move.
No! Oh my gosh. It would be 8 over 2 and then it would be 4.
Okay, so before you start discussing, I still need your attention. So I need you to pause for a minute. I'm waiting for your attention. Still waiting. Okay, remind your neighbor that I'm still waiting. Okay, I know I have your attention when you're not talking and you're looking at me. Thank you. Okay, so what I would like you to do is if you have the same answer as your partner, that's awesome. That's great, you agree. If you do not have the same answer, what I would like you to do is on the back of your problem, I would like you to write down, just one of you, on the back of one of your problems, write down what questions you have about this problem, and then we're gonna come back to this on another day, okay? So, again, if you and your partner agree, that's great, okay? If you don't agree, you're gonna turn one of your problems over and you're gonna write what questions you have about the problem. And then I'm just gonna come around and check in with each group. Okay, go ahead.
But you always want to
You did it wrong in the first place. Don't look at this time.
simplifying radicals. You have to do the simplifying radicals because perfect example 3 times 2 in the radical.
I agree with both groups that it needs to be simplified, but neither one of us is doing it exactly correctly, so maybe that's one of the questions. If you do it like this, how do you simplify radicals?
This is just a one.
Yeah, you agree?
3/4 and then like negative 4/5 is what I got.
Oh, yeah. Did you have this time?
Okay, I'm ready to head back to your seats, but have one person, okay, stack your papers right up here. Right up here at the whiteboard. Okay, one person bring your problems right up here. All right. Okay, so you need your hands free. Okay, so put your writing utensils down. Okay, so we're gonna add 2 more definitions to our chart, but I want to review the 3 that we already have. Okay, so who remembers the sign that we use for ratio? Ratio, can you show me? So ratio is comparing 2 numbers. Nice job. Okay, what about means? Inner proportion, it's the 2 numbers in the middle. Good. So means, the 2 numbers in the middle. I like to see everybody do it. Okay, 2 numbers in the middle, means. Here, repeat after me. 2 numbers in the middle, mean. Okay, we're gonna do it again. All right, 2 numbers in the middle, means. Okay, and extremes, right? Extremes, the first and last number.
First and last number.
Extremes. Good, one more time. First and last number, extremes.
First and last number, extremes.
Nice. Okay, so we have, we made some predictions about similar figures and scale factor on Monday. Okay, and I'd like to talk to you about the definitions for those 2. Actually, you were really close on both. Okay, so you obviously have some experience with these 2 phrases. So, similar figures have congruent angles and equivalent ratios for corresponding sides. So that's pretty dense, like there's not a lot of words there, but it's a pretty dense definition. We're going to talk a lot more about that today. So it's congruent angles and equivalent ratios for corresponding sides. Similar figures. So give me a minute to write that down. So again, it's congruent angles and equivalent ratios for corresponding sides. And I think there were a couple of you that had the exact definition in your prediction. Not surprisingly, this is a concept that you should be familiar with. Okay, so before you write the second definition, I'm just going to have you put your pencils down and I give you the signal for similar figures. Okay, so we're going to make a triangle. Triangle. Okay, so similar figures have congruent angles. Okay, and they have equivalent ratios for corresponding sides. So we're just gonna say congruent angles and equivalent ratios. Congruent angles and equivalent ratios. Okay, show me again. Okay. Congruent angles, equivalent ratios. Good. Congruent angles, equivalent ratios. That's similar figures. Okay, similar figures. Okay, similar figures.
Congruent angles and equivalent ratios.
Congruent angles and equivalent ratios, similar figures.
Similar figures.
Alright, let's try scale factor. So scale factor has equivalent ratio for corresponding sides. Okay, scale factor has equivalent ratios for corresponding sides. So I'm going to write that down. Okay, and then in ASL, this is the sign for F, or at least I think it is. And so we're going to use for equivalent, what's that? Are you in ASL? Okay, is anybody in the class in ASL? Okay, is that, show me F. That's F, okay, good. So this is the sign for F, well, it's a different language, so you might not be familiar with it. So equivalent ratio for corresponding sides, so we're going to use, scale factor. Okay, factor is an F, so equivalent ratios for corresponding sides, scale factor. Okay, so equivalent ratios for corresponding sides. Okay, so we're going to say equivalent ratios for corresponding sides, scale factor. Okay, repeat after me, scale factor.
Scale factor.
Equivalent ratios for corresponding sides. Scale factor. Good. All right, and show me similar figures again. Show me similar figures. Similar figures. Okay, and this is congruent angles and equivalent ratios. Okay, congruent angles and equivalent ratios. So how are these two phrases related to one another? How are they related?
They both have.
Yeah, Sean.
Equivalent ratio for corresponding sides means that like the side IJ would be corresponding to side CB. And then similar figures just means that you can put that scale factor into use.
Okay.
Good job.
Anyone else want to take a shot at it? Yeah.
So what I have to say is that congruent angles, so one of them is just saying that one side is the same, but the other one is saying that the whole shape is the same.
Okay. They're actually, similar figures have a common scale factor. Okay, so if I took these two triangles, okay, in this diagram, if I took this one and I moved it and laid it over the other one, you can see that all of the angles are the same. Okay, they're the same. So it definitely has congruent angles, and that's because I actually took one of these and scaled it up to make the other one, right? So if I get rid of this, and I just copy and paste this shape, they would be the same size. Okay, so these two triangles are the same size. In order to be similar figures and not congruent figures, they have to have the same angle measures. The angles are going to stay the same, but the side lengths are changing, and they're changing by a scale factor. So something could be twice as big, or 3 times as big, or 1/3 the size, right? So you can scale up, or you can scale down. How many of you worked with scale models when you were like Anybody ever put together a model growing up? Model car, model plane? Okay. All right. So our learning target today is that I will determine if shapes are similar and find their scale factor and find the scale factor of similar figures. So we're going to determine if shapes are similar and find the scale factor of similar figures. So we're still pretty new in this unit, but I want you to kind of think about what that means. Okay, and how we might use it. Okay, so I want you to turn and talk to your neighbor. How might we use this? How might we use similar figures and scale factor? Either in school or in a job. Like you can think of a job that you might use this in. So turn and talk to your neighbor. How might we use this?
If you're a triangle like worker,
Like the same.
say if you like have to like work with triangles, if you're a triangle,
Like yeah, you want the same structure and the same how
if you like make Legos,
then you would
To like see how the structure holds up and stuff. So you could use that in your job to plan out how like to hold up, to plan out and then also for the shape.
Okay, so let's talk about this. So like put it back together. All right, here we go. So some of you were having some great discussions. I'd love to hear what you were sharing. So is there anybody that'd like to share with their class either what you shared or what your neighbor shared? Yes.
Like scale models of like
Okay. So what kind of job might use scale models?
like some sort of construction.
Okay. Sean, what do you think?
I think you need it when you're building stairs.
Okay. How could you use similar figures or a scale factor when building stairs?
Because everything's got to be the same.
Okay. So are similar figures always the same size?
No,
Okay.
but they can be.
Yes.
Stairs aren't always the same size.
That's true.
My stairs are all different shapes.
Yes. Okay, architect? Okay? Yes, Brandon.
Before you start with your furniture and stuff, you can like map it out online.
Yeah, any
Like a digital version of it.
anybody have any interest in going into like visual arts? Okay. We have a very generous company that makes banners who always donate banners to our school during Spirit Week. Okay, and those are things that you can take something small, right, and scale it up or down to whatever size the company you're selling the product to needs. So there are lots of ways that we could use scale factor. Yes, architecture, that's one that everyone thinks of. But what about anybody that makes a product, like cars or, I mean, what else could you think of?
what if you like a Lego brick maker?
Mm-hmm. Yeah, and they actually have those in like different sizes now. But you have to think about that. You want the thing that you're making to be proportional to whatever it is that you're modeling. Okay? What do you think?
Math teacher.
Okay? I definitely use similar figures on a pretty regular basis. Any other ideas? Okay, we're going to see some practical applications of using scale factor as we move through this unit, but we're going to start pretty abstract. Okay, we're going to start pretty basic, just to make sure you have an idea of this before we start applying it to real-world problems. Okay, so first of all, this sign for similar, okay, is not an equal sign, because it's not equal. Okay, this is the math symbol for similar. It's like a sideways S. Okay, so this math sentence says that triangle MNP is similar to triangle SRT. And they want you to list the pairs of congruent angles. Okay, so what angle would be congruent to angle M? I hear lots of you saying S. How do you know it's S? Dominic?
Because if you flip the first triangle, it would match up with that angle.
Yeah, absolutely. So just looking at the shape, right? If you change the orientation of the shape, Dominic's saying that we could kind of flip this, like rotate it, and we could map S onto M. But just looking at the name, how do we know that M is congruent to S? Yes, Dylan.
Because it is in the same place on each triangle.
Yeah, it's named, they always name corresponding vertices when they're naming a triangle. So we know that M corresponds to S, so those are congruent. And N is congruent to, everybody should be looking at the screen. N is congruent to R, thank you. Okay, and P is congruent to T, nice job. Okay, are there any questions about that? Yes, Sean.
So, when you have similar figures,
Mm-hmm.
are they, no.
Okay. We might jog your question as we move on. So let's go on to the next part of this. Wants to know what the extended proportion for the ratios of corresponding sides. Okay, what does it even mean? Wants an extended proportion. What's a proportion?
That's like part of it, I guess. We could say.
Yeah, well, it's definitely part of an extended proportion. What were you gonna say, Chelsea? Yeah, a comparison of two somethings. So a ratio is a comparison of two numbers, right? We talked about that. A ratio is a comparison of two numbers. A proportion is a comparison of two ratios. At least two, right? So back here when we're talking about means and extreme, AB equals CD, that's a proportion. Okay? Because it's setting two ratios equal to one another. It's two equivalent ratios set equal to one another. So a ratio is a comparison, and a proportion is like a comparison of a comparison. Okay? So first, before we can do this, we have to figure out what all our corresponding sides are. So we named all our congruent angles. I would like you to match up all the corresponding sides. There's 3 sets of corresponding sides. I'd like you to match those up. Okay, so take a minute and do that. Figure out what corresponds to MN, what corresponds to MP, what corresponds to NP.
MN is congruent to SR.
The corresponding sides.
And wouldn't it first be the other way around? Because it's to make it equal with the letters going. Yeah. Oh, are you saying NN? Be MN.
Okay?
Yeah.
Okay. So what corresponds to MN?
SR.
Okay. And NP.
That would change.
No.
Oh, you said, I thought you said.
Oh, I said N. So you thought I said NP?
Yeah.
That would be T.
Or T.
You're right. Good, you got it. Okay. So let's go over this. Okay, here we go. All right, Justice, can you give me the corresponding side to MN? Okay, and what side corresponds to, let's get this color so we can get it all on the screen. What side corresponds to NP? Jack?
TR.
Good. I'm just trying to write it in this same order. So you just want to name the corresponding vertices in the same order. Okay, and then what side would correspond to PM? Yeah, percent. Good. TS. Okay, so now we know what all the corresponding sides are, so we can kind of check that box. We know what the corresponding sides are. We know what a proportion is. Okay, now it's asking for an extended proportion for the ratios of the corresponding sides. So what's that going to look like?
Could you say that one more time, please?
Yep, we are looking for an extended proportion for the ratios of the corresponding sides. Here, corresponding sides need to create ratios. So how could we do that? What would that look like? If I know that MN and SR are corresponding sides, how can I use those to make a ratio?
Take, take 1 point from each to make a line out of it. So like MS and MR.
Okay? But the side links are already line segments, right? MN is a line segment. SR is a line segment. Here, let's highlight them. Right? Here's MN, here's SR. If I want to make a ratio of those two sides, what would that look like?
MN to SR.
Yes. Say that again.
Say it again.
MN to SR.
Yes.
Good job.
Okay, so we would say MN to SR. So that's a ratio. Now we need to make it a proportion. So what would that be equal to?
1, 2.
Give me another ratio. Okay, let's talk about our next set. NP. What would correspond to NP?
Nope, to root.
Correct.
To tur.
Exactly. Okay, and then what's our last ratio in our extended proportion? Turn and tell your neighbor, what's the last ratio in our extended proportion?
So then we have the old
Okay, so I just heard Sierra say it, so I'm just going to ask her to repeat it again. Sierra, what's the last ratio in our extended proportion?
PM to TS.
You got it.
Okay, great. I have a question. Would this still be an extended proportion if Sierra had said TS to PM? Okay, I see Allie went, nope, that's not right. Okay, why isn't that right?
Wrong.
Yes. So prior to this, right, all of our numerators were from the small triangle and all of our denominators were from the large one. And you have to be consistent about that throughout your extended proportion. So Sierra was exactly right, okay? This is PM over TS. So all of these side lengths are coming from our smaller triangle, and all of these side lengths are coming from our larger triangle. Okay? Questions on that? Awesome. I would like you to do the same thing, okay, with this shape, or these two shapes, these two similar figures. So now we have two quadrilaterals. So we have D, E, F, G is similar to H, J, K, L. Okay, and I just want you to create, we're just going to do B. I want you to create a proportion for the ratios of the lengths of the corresponding sides. Okay? So you're going to take the two similar figures and create an extended proportion like we just did. Remember, each side length has two vertices. So, previously we had one big long equation. So, remember these are similar, they're not equal, but if you create a ratio of these two, you consider these are two ratios from the numbers, right? So in the previous one, we had all of the smaller shape in the numerator. We're going to use side lengths, so you need two vertices. for each numerator and 2 vertices for each denominator. You're creating an extended proportion here. We're doing this again. Yep, we're doing it like this. So this is what we're creating right here. Okay, so once you finish yours in your notebook, you put you and your partner's name on the sheet I'm handing out. So our extended proportion, so I'm gonna start it. Okay, and then we're gonna, okay, and then we're gonna play a little version of Pass the Pen, only I'll be the recorder. Okay? So, alright. I need you to give me the denominator. You don't have to stand up. Nope, it's not. It is. Thank you. Nope. Okay, here we go. I'll take that. Yes, thank you. Okay, here we go. Okay, so I'm not sure if you heard you.
I said HJ.
Okay, so DE over HJ. Okay, so you can pass the pen. Someone nod at your table group.
Oh, we're still not on that yet.
Doesn't matter. You decide.
Of course, the girl.
Okay, Allie, will you give me the new numerator, please? I'm sorry? Okay. And the denominator?
JK.
Awesome. Okay, pass the pen. They don't have to volunteer, you get to choose. Alright, here we go. Alright. Chelsea.
Of course. Of course.
Okay, can you head together with your table partner really quick? So I'm going to give you the numerator and you're just going to give me the denominator, okay?
No scouts together.
Okay, so there's the numerator. Okay, head together real quick.
Together.
You got it? Okay, so here we go. Alright, so FG corresponds to which side length? KL. Alright, pass the pen. Someone in another group?
Oh, of course.
Okay, Taylor, yeah.
For big girl.
Last one.
GD
Good.
and LH.
Awesome. Okay, I'd love to hear what questions you have about naming corresponding sides, because the next part's not going to make a lot of sense unless you can name corresponding sides of similar figures. So does anybody have any questions about how to do this? How to set up an extended ratio? Just thank you for your question, Chelsea. Okay.
Just in order. So the first one's D, then the first one's H.
So just take a look. We did. No, that's okay. That's all right.
I didn't know if you always did that.
No, that's a great clarifying question. Thank you. What other questions do you have? Okay, awesome. All right, stand up. Okay, turn to your neighbor. Okay, turn and face your neighbor. Okay. All right, decide who's A and who's B. Decide who's A and who's B. Okay, raise your hand if you're A. Raise your hand if you're A. Okay, awesome. Raise your hand if you're B. Okay, A's. I want you to show the sign for ratio, and B's, you're going to say the definition. Okay. All right, A's and B's. Okay, looks like we might need some help with this.
No.
Give you a little reminder. Okay, if you need a reminder, it's on the screen. Okay, A's. You're going to give the sign for ratio. B's, you are going to say the definition.
You're B. You're the only other option.
Okay. I don't know. Can I just say anyone?
What? No, you have to say the ratio.
Okay, great, switch. Alright, now we're going to switch.
Thank.
Okay, B's, you're going to give the symbol, and A's, you're going to say the definition.
Of what? Ratio, just do it.
Ratio.
Average of two.
Okay, great. So we're going to move on to means. Okay, A, you're going to give the sign for means. And B, you're going to give the definition. Ready, go. You guys are on it. Okay, great. Switch. Okay, here we go. A's, you're going to give the sign for extreme, and B's, you're going to give the definition. Ready, go.
That's extreme, in a proportion to first last number.
Okay. Okay, when I say ratio, you say proportion. Ratio. Ratio. Great, have a seat.
That kind of recording.
Yeah, you're just in the video.
Okay, you guys are gonna get your break when we walk over to ER for the college fair. Let's move on. Okay, here we go. I'll wait for you. Okay, here we go. We are gonna start this first problem the same way we ended the last one. So I'd like you to start by just writing an extended proportion for this problem. Okay, you're going to start by writing an extended proportion for this problem. Okay, so you're writing an extended proportion for this problem.
Jump the one up on the floor.
What?
Keep writing what you got. Got it? But I want you to write it out, and I have a reason for it. So please write it out. Yeah. You weren't here the day that we talked about it. Okay, here we go.
Finishing.
So, I would like to hear your extended proportion, okay? Okay, is anybody brave enough to give us the whole thing? Extended proportion? Okay, Chelsea, I love your confidence, so I'm just gonna go back to you real quick, let's try it.
So JK over TU, then KL over UV, LM over BW, and MJ over WT.
Great. Okay, I hope everybody wrote that down, because now I would like you to replace the segment names. Yeah?
Wait, does the order you do it matter?
What do you mean?
Like, does it have to be like JK over TU first, or can like KL over UV?
You could do any of them first. Remember that it's an equation, so we can swap any of them out and it should still be the same.
Okay.
But the reason I asked you to clarify is because order matters insofar as that you should be naming corresponding vertices in the same order. Does that make sense?
Yeah.
Okay. Alright, so what I'd like you to do now is I want you to replace the name of the segment with the measurement that they're giving you. Okay, so I'll give you an example. So JK, the measurement of JK is 12, and the measurement of TU is 6. Okay, so I'd like you to replace the rest of the segments, okay, with their measure. Okay, what do you notice? What do you notice? No, you said something. Okay, they are numbers, yes. What do we notice about the ratios though? If we were to simplify all of the ratios that we get, okay, what would happen? Okay, what's my next ratio? Let's just go ahead and fill in the rest. Okay, Hannah, give me the next ratio. Great, 24 over 16. Okay, Dylan, give me the next ratio.
Me?
Yes.
24 over 16. Oh, no, we already had that. 24 over 14.
You have 24 over 14? That's all right.
Oh, is it supposed to be
LM over BW.
Okay, so this one wasn't right then.
No.
No, they're both.
Nope, they're both the same. Huh. Okay, so it's 24 over 14. Okay, and what's the last one?
6 over 6.
Okay, so what do you notice?
Oh no, I noticed that they're kind of counting because it goes 1, 2, 3, but then the last one is the numbers.
Hey, should there be equal signs between these ratios?
No.
No, why not?
Because the 14.
Because they're not equal. Okay, so are these figures similar?
No.
No, but they have congruent angles. Why aren't they similar?
Because they're not the same. They're not the same ratio.
Yes, the sides don't have the same ratio. They don't have a similar scale factor. Okay? So in order for these shapes to be similar, all of these ratios would have to be equal. Okay? All of these ratios would have to be equal in order for them to be similar. Sean, will you repeat that?
Yeah, what?
Do you need to repeat it again?
Yeah.
Okay, so all of these ratios have to be the same in order for the shape to be similar. So just because the angles are the same doesn't mean they're similar figures. You have to have the ratios from corresponding sides have to be proportional. They have to be the same. Does that make sense? Okay, so I've given each of your table groups, okay, has one of these 3 problems. And what I would like you to do is put you and your partner's name on this card, Okay, you're gonna write an extended extended proportion. Okay, and then if they are equal, you're going to give me the scale factor. And if they're not, you're just gonna write not similar. Okay, so you're either gonna give me a scale factor, or you're gonna say they're not similar. Okay, and then we're gonna have to end here. So this is gonna be your exit ticket. Okay, so make sure you and your partner's name is on the ticket.
Because look, 16 and 20 don't match with anything. 12
Oh.
What's that? What does that mean? Scale. So if they're similar, I'm gonna scale factor.
But they're not similar.
Then you're just gonna write not similar. So again, if they're not similar, don't give me a scale factor because it doesn't have one. You're just gonna write not similar. You're gonna write the letters first, but then you need to figure out if they're similar. Well, some of them are and some of them aren't. What are you guys saying? Will you help me? I need this crossed out. Yeah. Okay.
Oh, Monroe's on top.
I'll take your card.